In this video, we'll look at number 1, 3, and 4, which is to sketch a graph of each curve without using a calculator, labeling the coordinates of the y-intercept and at least one additional point. So we're studying exponential equations of the form y equals a times b to the x. By looking at this equation, I can tell that my starting value is 4, my multiplier is 1/2. So I know that this is going to be a decreasing exponential graph. So to find the y-intercept of any graph, we're going to plug in x equals 0. 4 times 1/2 to the 0 is 4 times 1, which is just 4. Again, 4 is the starting value, which is the same as the y-intercept. I want one additional point just to verify the shape of the graph. So if I plug in another value of x, 1 is an easy value to pick. 4 times 1/2 to the first power is 2. So my graph goes through 0, 4. My graph goes through 1, 2. And this is an exponential curve that is decreasing and approaching the x-axis. The x-axis is the asymptote of the graph. That means the graph approaches the x-axis but never actually intersects the x-axis. Let's look at an increasing exponential curve. So number 3, we have a starting value of 1/2 and a multiplier of 4. So the y-intercept is 0, 1/2. If we plug in x equals 1, we get 1/2 times 4, which is 2. So 0, 1/2, 1, 2. This shows that I have an increasing curve where the asymptote is still x equals 0. Number 4, we have a negative 1 as our initial value. So there's a 1 here and the multiplier is 2/5. So our y-intercept is at 0, negative 1. And if we plugged in another point, we would get 2/5 to the first power and then negative, so negative 2/5. So here I have a y-intercept at 0, negative 1. And then when x equals 1, we're at negative 2/5, so that's negative 0.4, so around 0.5. This is a negative starting value, which makes the graph flip upside down. So if this had been positive 250 to the x, the shape would have looked like this. But this negative makes the graph flip upside down, so the graph looks like this.